Okay, in the second part here, we're going to talk about a concept called generics. This is a common feature of object-oriented programming languages. It has comes under different names. In C++, it's called template programming, although it's a little different in each language. So Java uses this thing called generics. And basically, we want to understand the reason for making generic classes and then learn the syntax of generics in Java. So the idea of generic programming is to write classes and methods, algorithms, independent of the type of data being processed. Okay? And I want you to think about this dynamic array class that we're working on for the homework that holds strings. And it seems like a nice thing. It makes a flexibly sized array for strings. But if we want to do it for ints or doubles or characters, we would have to write a class for each one of those things. And what if we wanted to make an array that holds circles, the class we've been working on ourselves? We would have to then add another class for circles, but maybe we don't even have access to that code. Someone else wrote it. So we have to be, sorry, my computer's starting to get hot. Let's see if I can get it to not blow its fan. So anyway, potentially you'd have to write 1,000 versions of dynamic array, one for each type of object that you want to store in there. And so, and the code's exactly the same. It's just that, the getter returns a string or an int, the setter takes in a string or an int, and the array that's stored inside is a string or an int. So it's sort of frustrating that we had this nice class and we'd have to make all these different versions. And so generics is a way around that. Okay, so here is a class, and I guess I'm going to be changing this. So let's go ahead and write it. The idea of box is kind of like a wrapper class. It holds a value, and in this case, we're holding an int value, and that's all it is, right? So again, a lot of times these classes aren't like programs in the sense they have a singular purpose. You're writing some code to let other people use it and basically make their code a little more concise and elegant and readable. So in this case, we're writing a class that holds an object. And so we need to construct this class. And in there, I'm going to assign the instance variable with the parameter. So assign the parameter to the instance variable. And since the whole point of this class is to put primitives in and out, I'm going to have a get item that returns an int and doesn't take anything in. And its only job is to return the item. And I'm going to have a set item. So again, nothing comes out of this. It just changes the internal state of the object that's being used. And a new value is going to come in, and we're going to assign that to the instance variable item. Notice in this case, I used this .item to disambiguate between the instance variable and the parameter. Here, I gave a different name to the parameter, so I didn't have to use this in front of there, although I could if I wanted to. But I would say, again, general form is that you only use this in cases where you need to clarify whether it's an instance variable or not. And I guess that's really all this class does, right? So we store a value, we create an object using a primitive value, we get the value out, and we set it. And we should test it down here. So I'm going to make a new box object. New box, I'm going to store 2 in it. And I'm going to print out getting the value from there. So b.get item, and hopefully gets that 2 printed out. And I'm kind of got some space creep going on here. Semicolon. Okay. So if I run this, hopefully we get a 2. Okay. So what a nice little class I have. Holds a value, not very useful. What if I wanted to hold doubles instead? Again, I would have to write box for double or something like that and put in double, 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 double. But notice the basic structure of the class is exactly the same. So when you write a class, you can add what's called a type parameter. And basically it means that when you create an object of the class, you basically declare the type parameter, and you can use that type parameter inside the class in place of a specific type. All right, so that's a little vague. So let me show you what this means. Basically, when I declare the class inside what's called the diamond here, I declare a type parameter. This can be anything you want. It's like the name of a parameter, basically, right? And I will say that for historical reasons, we do tend to use these funny capital single letters as type parameters. Then, instead of an int here, I'm going to use that type parameter. At some point, an actual type gets assigned to this type parameter, right? Like an int. In that case, all the t's turn into ints, and this then works for that particular thing. So you can't just do a query replace and change all your ints to t's, because maybe you have like an int count here, for loop or something. You don't want to change that to some other type like string. So you have to kind of be selective in doing this. But basically, I'm going to build it with an object of a certain type. I'm going to get that certain type out of this class. I'm going to assign a new one of that particular type. And okay, so now this is now called a generic class. It doesn't have a known type. It basically, when you make one of these, you're going to say what type you want it to use. Okay. So what changes down here when I make one of these things? It's complaining to me. It says the constructor box object belongs to a raw type. What does that mean? References generic type should be parameterized. Blah, blah, blah. It's basically saying, hey, I need to know what type I'm actually building here. The type inside the diamond cannot be a primitive type. So even though I'm sort of wanting an int one here, I have to use that wrapper class integer instead. Okay, this thing here can still be a primitive 2 because of autoboxing. It's going to take that primitive 2, and when it goes up here, the t is now an integer type because that's what value was passed to this type parameter, and so t takes on an integer value. This primitive 2 is autoboxed into an integer. All right, so kind of complicated for sure. I need to leave this the parameter type, so if I make a different kind later, it'll work. Okay, what happens if I run this? I can't even see it. 2 comes out. Okay, so what happens? Primitive 2 gets assigned here. This is of type capital I integer because that's the type we're building this thing to be. The 2 gets autoboxed into a capital I integer and assigned to this integer item. Down here I say get item. It returns an integer type, and the value of that gets extracted and printed as a 2. Okay. Now I can make a different box type by putting a different type parameter in there. I'm going to pass in David. And I'm going to get the value out of this S object. If I run this now, 2 comes out of David. So this one chunk of code here can hold integer types, if that's what you declare it to be, and it can also hold string types, if that's what you declare it to be. Right? So you're not saying, hey, from here on out, all boxes are going to be integers or all boxes are going to be strings. It's on a per object basis. When you make it, it figures out what type it is, and it basically turns all these t's into that type just for that object. Okay. So you can imagine in your dynamic array, you could have made that with this type parameter and then stored in different values based on that. I will say, actually, if you try to do that, there's some further complications based on type safety. If you make an array of these parameter types, it's a little more complicated. There's a way to solve it, but we're not going to get into it right now. So if you're eagerly try to experiment on your dynamic array, you're going to run into some issue when you're creating an array of this generic type. All right. Now this T thing is funny. Basically just means some type, but there are other sort of these single value uppercase things that are used kind of frequently. They're designed not to look like regular variables, right? You want to be able to look at that and say, oh, that's one of these type parameters, and I should expect that at some point it's going to be assigned a real type. I think it makes the code be a little less readable. It takes a while to get used to. You know, I want something like int here or integer, and it's just this funny T floating around in space, right? But again, in your mind, just realize that that's going to be turned into some sort of valid type parameter at some point. The diamond here again must be a non-primitive type. It's pretty common for you to forget that and try to put in an int or something like that, and it will complain and say, well, I don't even, it's trying to do something else there to fix it again. Again, the fix is not very good. But basically, it needs to be an object type, and which is one of the reasons that there are these wrapper classes, is to allow the generics to work properly so that primitive type things can be part of these generics. You can also write generic methods. So let's say I had a method that print out values in an array. Well, you hate to repeat that for int arrays and double arrays and string arrays and so on. So here I can make, between the static and the return type, I can make a showing that it's a generic, right? So here we attach it after the name of the class. Here we put it between right before the return type. Then we can use it inside here. So here this is giving me an array of E type. Eventually that'll be turned into something, integer, string, whatever. We pull out these values one at a time. And again, that's going to be turned into an integer or E or whatever. I mean, integer or string or whatever. And we just print it out. So this thing would work on arrays of any object type. When you call it, you just call it. You don't have to put like the diamond here with, you know, double or something like that. It figures out that these are connected to parameter type and this, and it infers it from whatever is going in here. Okay, so why generics? Well, it's very convenient. We only have to write one class, and we make it a generic type, and then it's usable by a whole bunch of different types. So that's great. So it's the efficiency of us writing stuff. There's maintainability. Again, I can just change it in one place, and it works again for all those different classes. So that's also great. And correctness. You're sort of not cut and pasting this a million times and then making one int and one double and forgetting, you know, not just doing it correctly. So the fewer lines of code you have to maintain, the better, basically. Some disadvantages: it's a little less clear code. There's a little bit of a performance hit as it sort of figures out what type it is and so on. When you make mistakes, the compiler errors, the exceptions you get are much more complicated, and you have to sort of force yourself to read them. If you thought it was bad before, it certainly is bad now. And Java does this in a way where basically, when I say this is a string type and it's a generic, it kind of tries to forget that it's a string type for a while, and it does a little bit of some sort of funny business to make this all work out. Some of the way C++ does it actually is a little cleaner, and you know, if you stay with the program, you'll see C++ in R3505 and see the template programming there, and it's actually much more powerful in that context. But for the most part, you're going to start seeing this kind of diamond with a type inside it, and you need to recognize that this is a generic class. This is the type you're building that specific instance of, and it has this kind of syntax. Okay? And again, we'll be using this again more this week. All right.